So this video, I'll be going through a rationale on how to increase mescaline and alkaloid contents in Trichocereus and Lophophora to their genetic potential. Obviously, each plant will have a different limitation and a different profile to others, and some clones should, in theory, have more content than others. But since we're all cultivating these plants in different growing conditions, be it soil, nutrients, watering, climate, sun exposure, etc., we'll all have different concentrations of mescaline and concentrations of different alkaloids in the cuttings, regardless if we harvest at the same time and the same amounts. So in the past, in the internet, we have read about papers, I think in the 70s, where they would inject dopamine and tyrosine and dopa in hopes to increase mescaline content and also to find out the biosynthesis of certain alkaloids. Like, they wanted to find out from where the mescaline was derived from. And in those papers, which I think has risen recently on DMT Nexus, I think it's around like 5 or 10% success rate. And I'm sure that there are some people that could probably have higher success rate nowadays. But the main issue with it is like it's impractical to inject it with some sort of syringe or something. Even a larger gauge syringe, it doesn't seem very practical. So we already know the pathway for the biosynthesis of mescaline. It's been reported on 2 or 3 papers, and I'll post a diagram on the pathway it takes. And we see from step by step that it goes from tyrosine to dopa, and then from dopa it goes to 3,4,5 trihydro B phenthine, however you pronounce it, and then finally mescaline. So in my idea that I haven't seen discussed online is, rather than just trying to dope the cactus, we would try to facilitate these processes. Recently, I think in the past 5 years, there has been a paper, there's been an experience where someone had access to actual analysis of their material. Someone set up an experiment where they did several cuttings, and then they had like a top half and a bottom half, and one was extracted instantly and the other was 3 months in a dark closet, I think, or a dark closet, or a dark shelving. And I think it was like 6 out of the 8 specimens that he experimented on, only 2 of them did not have an increase in mescaline content, and the rest had nearly double mescaline content. So many people now suggest, as a minimum, you your cuttings. I don't know if we're calling it curing or stressing. But yeah, we're leaving them 3 months in a dark place. That's a suggestion for now for increasing mescaline content. So I try to keep that in mind while I was also reading and studying how to increase the biosynthesis of mescaline through their already known and published pathway. So in general, we would just grow the cactus as healthy as possible, nutrients and everything, and you would have the most biomass with excessive nutrients, watering, sun exposure. Optimal conditions would have optimal growth, but you would have less concentration, not less quantity, but less concentration of the alkaloids. That isn't a problem necessarily, but the downside to that is you would have to use more material to extract, and you would have to work with more materials to start with. So instead of using just a rough number, let's say instead of using like a kilo, which is a lot, let's use a kilo. Instead of using a kilogram to extract, if you grew it optimally, it would have less content. So a stressed or optimally grown Trichocereus for mescaline content and not for growth, you would use, let's say, 800 or 700 grams instead of a kilogram. I don't know if you guys understand my rationale on that. So since you would just use less content, which for some is important since not every country has access to solvents and other bases and acids. But I'm not going to discuss extraction since that's not of interest to me, but rather steps on how to increase mescaline content. So we would just grow a cactus normally, and at a certain point we would try to increase its tyrosine hydroxylase, since that's the first step towards mescaline. It starts at tyrosine. In the past, like I mentioned, people would increase tyrosine by injecting it, but you would just grow it naturally and that content would be there. Instead of trying to increase it, you would just try to facilitate its conversion through that enzyme that does TH, or tyrosine hydroxylase. So there's a few different methods that I found in different papers. They may or may not work on Trichocereus, since they were various different papers on various different plants. Some of them were on potatoes, and then some of them were on different not salviates, that colorful colloisa, and a few other papers that I saved, but I don't have the plants that they worked on. So the first step, you would use a low dose of aspirin as a foliar spray, and since Trichocereus or cacti are cam plants, you would preferably do this at night, since there's a possibility of higher intake. The low dose aspirin contains, I think it's silic acid. I don't have a scientific background, so excuse my pronunciation and everything, but that salic acid would upregulate the TH enzyme, and what I calculated from the papers, it's about 1 gram per 3 liters of water would be the concentration. Now I'm not sure how frequently you do that, different growers apply it to tomato plants for more resilience. They suggest it every 2 weeks. I think that's a good baseline. Everyone experiment and try different amounts for that. And another benefit for a low dose aspirin dosing of the cactus would be an increase in cold tolerance. Another way to increase tyrosine hydroxylase would be adding black pepper to the soil. The black pepper would increase iron and manganese, which are the two nutrients or minerals that regulate and initiate TH in many plants. So that would be a way to facilitate in the biosynthesis of mescaline to the next chemical. The pepperine and the black peppers also have some benefits I can't remember off the top of my head. And I think it just increases other factors of resilience. So another way to do that would be the growth hormone, a basic acid, or ABA. It's a growth retardant. I wouldn't use a chemical directly, but it is naturally occurring. One way to do this is just stress in general and also damaging the growth tip. Usually upregulates ABA production in plants. So from the increase in TH, which is the first process, we would now have more DOPA and hopefully minimum amount of remaining tyrosine. So from the DOPA, we would want to do, I think it's DOPA decarbonization. From my research in that, people do this with weed as well. They have several different methods of doing decarbonization. But from like the steps that I mentioned before, where people are dark stressing their cuttings, the dark stress in itself should increase or should help in this conversion from DOPA to the 3, 4, 5, the following step in mescaline biosynthesis. But when I was researching deeper, trying to find out how the dark stress comes out, different plants have different effects to dark stressing or dark treatment. In some plants, indeed it does increase alkaloids in general, but in other plants the dark stressing actually decreases tyrosine hydrolysis and DOPA decarbonization. So I'm not sure if the dark stressing is actually helping from the dark stress itself or another process. In a way to try to support the dark stressing, I try to find a process where it'll actually help trying to support this theory. And since cacti are can plants, which is different from the other plants studied in the papers I've read, the dark period is where a PEP-NAD plus process occurs, where it converts malic acid to energy. So since we're dark stressing it, it wouldn't create more malic acid to convert. So since cacti aren't photodependent, and I'm pretty sure they're on the circadian rhythm, the process to convert the acid doesn't occur since there's no light. So rather than using decarbonation process, decarbolysis, decarboxylase process to convert the malic acid. It uses that same decarboxylase process to convert the dopa into the 3,4,5 trihydroxide. But again, this is just trying to find a case to support it. I'm sure there's other processes that could help it. Maybe the dark stressing does work just like in other plants, but directly I couldn't find a paper where dark stressing increases this specific process. Some people also suggested putting the dark process in a cold location. Cold stress is also another factor. The cold stress from the papers I've read also decrease these processes. The enzyme that does these conversions is optimal in higher temperatures. So doing this in the summer would be better with the temperatures, or even putting it in the dry oven or something, similar to how some people do it with weed. So maybe that's the process, or maybe it's just from the other processes that we'll continue into. So now we're at 3,4,5 trihydroxide biphenethylamine. I think that's how you say it. From here, the main process is to mescaline would be an increase in ethylene and methylene. Under any stressful condition, plants would produce their own ethylene. But obviously in this process we want to optimize it so that there's a maximum conversion rate. The best way to do this would be to put some apples or bananas with the cuttings while they're curing for an indeterminate period of time. For now, we have this time frame of 3 months. In theory, we could reduce this by over 50%, increasing the methylene or the ethylene content. People do this to increase maturity or ripening in tomatoes. They put the tomatoes, unripe tomatoes, with a banana, and the ethylene released from the banana increases the ripening process, where it turns from green to red in a matter of a few days rather than a few weeks. A better fruit than banana would be apples, since it has about 10 to 100 times more ethylene production released. So that would work better at helping increase the conversion rate for this methylene, or for the mescaline biosynthesis. And in general, humans have enzymes as well that will convert the dopa that isn't converted from the dopa decarboxylase process, and our bodies would convert it to dopamine and serotonin. So that's where some of the pleasure from consumption comes from, probably, and not only the mescaline or other alkaloids. And like I mentioned, let me read my paper here. The cold temperatures, like I mentioned, it reduces the DD, which is the dopa decarboxylase, and UV exposure increases it. So the dark exposure might not be the best way. We would have to do more controls and a few experiments to find that out. And yeah, Higher temperatures in nearly all the papers suggest that enzymes work best in higher temperatures rather than cold temperatures. At converting, in most papers, the most accumulation of alkaloids are from hot days and hot nights versus cold days and cold nights. So, to summarize, my suggestion for the maximum mescaline content for cacti would be before harvesting, doing a few applications of aspirin and probably putting black pepper in the soil. And then the dark process, I'm not really sure if that's necessarily what's happening. The dark treatment could just be from the drought. And I skipped that part. The drought increases the TH conversion and the DD conversion, which are the first two steps. And the 3 months without watering in the dark would be where the drought comes from. For drought enzymes, high light, high temperatures, and droughts are all synonymous and interchangeable with activating the enzymes in other plants. So even if you water your plant, if you have excessive heat or excessive light, it would be the same as not watering your plants. So I would propose that as a test to see if a drought period alone without a dark treatment works at maybe a higher conversion rate of the mescaline. So again, you apply aspirin at the first process. A drought period also does the first two processes. We would need to re-examine the dark period, and if we consider that the dark period works, we would also want to retest it with dark and higher temperatures and dark and cooler temperatures, where in most plants a higher temperature would result in more alkaloid accumulation. I already mentioned if the dark period works, it would probably be through the PEP-NAD process in the CAM photosynthesis. But that's me trying to find a reason where it works rather than just reading into how in other plants it doesn't help but actually reduces conversion rates. And then from the 3,4,5 trihydroxide, that's where the ethylene and methylene would be needed for the final conversion to mescaline. From here, I'm suggesting we cure or ripen the cuttings with a bundle of bananas or apples, similar to how people ripen tomatoes. You wouldn't want necessarily fresh plants, I'm pretty sure, but you would have to research on your own, that near maturity, not green bananas, but like yellow starting to turn brown, that's where the most ethylene is released. Bad apples are where the phrase comes from, a bad apple ruins the bunch, is where one apple that's already extremely ripened releases an excess amount of ethylene, which increases the ripening of the other apples. So we would want that to ripen the cuttings and in turn increase mescaline content. So yeah, hopefully more people experiment with this. Hopefully you guys enjoy this content. Please hit the like and subscribe so that more people can find this content. I'll be posting this on a few different forums so that the discussion can happen more freely. I'll be posting on DMT Nexus. I think I have my account still. On Shroomery, on the Nook. And if you have any questions, you can always post on the comments in YouTube. And hopefully you guys subscribe so that it helps the algorithm share this with more people. Like I mentioned, I don't necessarily think that the clone community is really helpful. We have a few hundred clones. I know that some of them actually do deserve a name, but with so many, I think that only phenotype should actually be named, and only if they're actually bred in breeding projects, so that we can follow the lineage. Most quote-unquote clones, when they're open pollinated, it's the same as just having, let's say, Burgesi or just Pachanoi, and the clone doesn't actually matter. For it to matter, you would have to self-pollinate, which isn't necessarily the easiest for most. It would require a few more expertise. And then you would actually have to backcross for some of them as well, so that there's less variety in the genetic makeup of the seeds, which isn't occurring much. In the beginning, there were a few SS crosses that were backcrossed, and those came out pretty well. But let's see if the clone names hold up after these optimization on growing and curing the cuttings. Let's see if they hold up. Hopefully this helps someone. Hopefully someone can experiment and prove some of these theories. I think the best theory here would be curing the cuttings with bananas or apples, and rather than leaving it 3 months curing, you leave it for a month and see how it compares to not curing and compared to 3 months. I think that's the easiest to test and would have the largest results at the end. As far as the dark treatment, I think it's more to do with the drought conditions than the actual dark period treatment. As far as ABA treatment, I personally wouldn't add the growth hormone directly. If you want for it to naturally increase ABA production, like I mentioned, stress in general increases ethylene and ABA. And another way is cutting the growth tip increases ABA production as well. And it changes the regulation of other hormones and auxins and that stuff. So yeah, this is another long video. Hopefully there's a discussion on this, and hopefully one of you hobbyists on the Nook and DMT Nexus pick up on this, and it helps the community out. In the future, my next major video will be on manipulation on some growth of Trichocereus based on a few harvesting styles. Not harvesting necessarily for skins or cuttings, just I guess pruning. That's my next video. It's gonna be a while since we're still in winter. For everyone else that's following along, if you guys have any other ideas or suggestions on future videos, I like experimenting a lot. Some things are not practical for me to experiment myself from a lack of chemistry and access to certain things. I do think the internet is mainly for sharing ideas so that other people can practice it and test it. And yeah, after that, I think the main thing will just be me doing some wide crosses, and hopefully in a year or two I'll also try to induce flowering on Trichocereus. And yeah, that's it. Like I mentioned, I think that we should stress seedlings out from the get-go. I know there's a large resale incentive for mass growing in optimal conditions, but if we can find those seedlings that have great growth in suboptimal conditions, those would be best, even if their content may be a bit lower. And since we can't really tell their content without growing it for a little while, I just think that resilience is more important than other factors. And for everyone else, there are methods of testing content on seedlings. There was a paper published recently where they just take a very small cut on seedlings. I think it's like 1 gram or 5 grams, and they have micro extractions. And the dude did a pretty good work on doing a fairly simple extraction for quantitative amounts of mescaline. So look into that if that's your interest. If you have the ability to test my theory on adding apples and bananas, or bananas, not both, one or the other, that would help. Another thing I just remembered now, putting banana peels in the soil it won't nourish necessarily the cacti, but the very high content of dopamine in the banana peel may, again, I have very little research on this, I haven't researched that out really, but there may be an uptake in dopamine through the roots, maybe even a foliar spray on the cacti at night with banana peels. Not for the potassium, not for the nutrients, but specifically for their dopamine content. I didn't write this down in my little script that I was reading from, but I'm fairly sure the dopamine content is around 700 micrograms. I think that's around, yeah, somewhere around there. But like in comparison to other natural sources, the banana peel has a fairly high amount of dopamine, which instead of injecting like in those papers in the 70s or 80s, I think a foliar spray or even just a soak or just randomly placing banana peels, besides the increase in ethylene, may increase the dopamine in the plants. But again, I don't know the uptake of dopamine based on roots or even fuller spray. And one more thing on bananas. Ethylene in pineapples is used to induce flowering, but they are not cacti, and it doesn't induce flowering in every banana or every family of plants. Someone could experiment with that, placing apples or bananas near the apex of mature Trichocereus to help induce flowering. That's another experiment. It's not what I was going to experiment with, but someone else can do that. So if there's there's lots and lots of things we can experiment with. I think we should always experiment on things, even if the norm or what's accepted goes contrary to that. We always learn through our mistakes. And yeah, I think I'm rambling a bit. I think I shared everything. In this video, I'll try to add figurines and things through post-editing. And yeah, this also works not only with Trichocereus, but also with Lophophora. You don't necessarily need the entire cutting for these enzymes to work. You could also just harvest the skin. I'm sure there's a limitation, like you wouldn't want dry powder and try to do a conversion adding banana peels. You would still want a fairly fresh skin harvest where it's not dried out completely and it's still alive. So like, you guys get what I'm saying, right? Like you can harvest it, but it doesn't need to be a full cutting, and it should in theory still work out. And during the curing or drying of the cutting skins, different people dry different ways. Just full sun exposure to dry it out, to powder it, works. It has the UV exposure and it has the heat. And oven baking at 60 or even 80 Celsius works with weed, and it should work with these skins. Again, this is very theoretical. In practice, it should work out completely. And yeah, let me know what you guys think. Please comment, share, subscribe if you can to help my channel grow. Share if you have any ideas that you would want me to experiment with. My channel isn't for learning basic cultivation, it's just more experiments. If you have any basic questions, I can help you out, but there's many channels that do that. Like, what's his name? San Pedro Mastery. He has a pretty good basics on growing San Pedro and peyote from seed. I do think he over nurtures his seedlings, as do most people. I think that exposure to adult conditions as early as possible is best. 1 month or 2 months is more than enough. Obviously, sunburn is a factor, so you wouldn't put it directly in full sun, but I start all my seeds in their final location and just use a double shade cloth and reduce that gradually. But at around 3 or 4 months, all of my seedlings get full sun exposure, and there's around a month of slow growth, and after that they're completely tolerant to the higher light exposure. with these, like I mentioned, I could be wrong, and these could be the higher content seedlings, since another experiment, which I'm not doing since these grow slow, but is another good way of selecting or pre-selecting seedlings, would be ethylene exposure to low light grown seeds. The increased ethylene, which these, like I mentioned, stress in general increases ethylene production in all plants. Ethylene in seedlings causes a triple response where they grow compact, they grow curved apex and whatnot. If you have more interest in attempting to pre-select, you could pre-select a mutant that is very ethylene sensitive, where they would have the triple response. A ethylene insensitive, I think, would be a bad clone, since, or maybe it's good, I don't know. I guess it could be good if it continues the conversion process. Maybe that is a good experiment. Yeah, I actually might consider that next time. Next time, I'll be selecting seedlings. I'll try to apply ethylene to their low light conditions, and the seedling that grows the most would be ethylene insensitive, so it doesn't affect their growth. Yet, it should still convert the alkaloids to mescaline. It just doesn't translate to reduced growth. Yeah, I just figured that out. Yeah, that's a good experiment. So yeah, that's another experiment in the future. It may take a long time for me to do that. And selecting and breeding a ethylene insensitive mutant would be very interesting, especially if it doesn't affect their alkaloid content. So for all you mass sowers, you should consider trying to select a ethylene insensitive seedling, where during the exposure most seedlings will be uniform, and a very few should be much larger and a very few should be much smaller. The much smaller would be ethylene sensitive, and the much larger would be ethylene insensitive, which may prove to be a very interesting seedling if its content is high, yet it isn't affected by stress as much. But yeah, I'm starting to ramble. Hopefully you guys enjoy this. Share if you guys can to similarly interested hobbyists. If you guys are able to experiment, please share your results online, on different forums, on Reddit, on this YouTube channel. And yeah, till next time.